In this video, we're going to have a look at one of the more difficult uses of differentiation, which is in optimization problems. So to do this question, we're going to use two facts. The fact that the volume of a cylinder is given by the cross-sectional area, which is pi r squared, because it's a circle, multiplied by the vertical height. And also that the surface area of the shape is given by the areas of the two circles on top and bottom, which is 2 pi r squared for both circles, plus 2 pi r h, where h is the height. Great. So it tells you that there's a radius of x and a height of h, and it's also told you the volume is 60 millimeters cubed, and then it wants you to express h in terms of x. Now it's given us the volume for one specific reason, and it's so that we can make this equation here equal to 60. So let's do that to start with. Replacing our radius with x and height is just h, we have pi multiplied by the radius of x squared multiplied by the height is equal to 60. We can find an equation for h in terms of x from here by making h the subject. Divide both sides by pi x squared, and we get h equals 60 over pi x squared. And that's everything for part A of the question. Moving on to part B now, it asks us to show the surface area is given by this equation here. Now I mentioned before that the surface area is given by 2 pi r squared plus 2 pi r h, and if we compare what we know about an equation compared to what we want to get to, the radius is x, so we know where 2 pi x squared comes from. But in our final equation, there's no h term. So that tells us that the h that we found before, the expression for h, we're probably going to have to substitute that into this second expression here to remove the h. So let's take that step by step. We have 2 times pi times the radius of x squared plus 2 times pi times the radius of x multiplied by, instead of h, we're going to substitute in 60 over pi x squared. Once you've done that, you see that the pi's cancel out, a power of the x cancels out, 2 times 60 is 120, so this term just becomes 120 over x, and this first term is just 2 pi x squared, so this essentially goes to that. Perfect. Now in part C, let's do it here, it says use calculus to find the value of x for which a is a minimum. Now, what do we know at a minimum? We know that when you differentiate the a equation at a minimum, in this case with respect to x, it's going to be equal to 0, because a minimum point is a stationary point where the differential is equal to 0. We're going to start by putting a in a format where we can differentiate it, so putting it all in one line. 2 pi x squared, that's already on one line, but 120 over x, we're going to write that as 120 x to the power of minus 1. This makes it easy for us to differentiate because, well, x squared differentiates to 2x, and 2 pi multiplied by 2x is 4 pi x. 120 times minus 1 is minus 120. Put the x there and subtract 1 from the power. Minus 1 take away 1 is minus 2. And we want to find where this dA dx is equal to 0. In order to solve this, I'm going to write x to the minus 2 as if we were dividing it by x squared. Once you've done that, you can multiply every term by x squared to put it in an easier format to solve. So let's do that. 4 pi x multiplied by x squared is 4 pi x cubed. When you multiply that second term by x squared, it'll cancel out with the divide by x squared, leaving you with just 120. And we say that's equal to 0 times x squared, which is just 0. From here, you can just rearrange for x. So you add 120 to both sides, divide both sides by 4 pi, which will get you to x cubed equals 120 over 4 pi. And then you cube root both sides to get that. X is just equal to 2.12 actually. Perfect. I'm going to rub some of this out just so we have space for the rest of the question. But the answer to part C is just 2.12. So I'm just going to write that out. X equals 2.12. It then asks you to find the actual minimum value of A. So we know that the minimum value of A happens when x is equal to 2.12. So we just put x equals 2.12 into this equation. So we say a is equal to 2 times pi times 2.12 all squared plus 120 over 2.12. When you put that in your equation, in your calculator, you'll get 84.842, which then just rounds to 85 to the nearest integer. So we can just write 85. Moving on to part C, it's asking you to show that this value of a is a minimum. How we show it's a minimum is we show that second differential, d squared a over dx squared, is bigger than 0. So, okay, I rubbed out dA dx. So let's find that again quickly. Actually, I'm just going to write out. I'm sure you may have written it down. It's actually just this. And then d squared a over dx squared, the second differential, is what you get when you differentiate this differentiated equation. 4 pi x will just differentiate to 4 pi. Minus 120 times minus 2 is positive 240 x, and then you subtract 1 from the power. Minus 2 take away 1 is minus 3, so it's to the power of minus 3. How we show that's a minimum? Well, first of all, x to the minus 3 is the same as 240 over x cubed. And if you put the value of x 2.12 into this, what you'll get is that this whole thing is bigger than 0. And because the second differential is bigger than 0, and the first differential is equal to 0, when x is 2.12, we say that at this value of a, it's a minimum. Hopefully that all makes sense, and if you have any questions with anything, just let me know in the comments. Otherwise, be sure to like the video if it helped, and I'll be sure to make more questions about optimization, so keep a lookout for them. They're quite difficult.